Hi guys, my name is Ayla and I'd like to welcome you to this video series called Modeling in RFEM 5. Before we get started, I just want to let you know that we are within this video series really focusing on modeling, and that's why we might not cover some topics in detail, but if you are interested in any other topics, just let us know and you can write in the comments below. I would also recommend you to watch our tutorials RFEM 5 for beginners. But let's get started now. So opening up the program RFEM, this is what you will see at first, the new model window. Here we can enter the general model data such as the model name or project name, the type of model, and we can also classify the load cases and combinations in this window. We will call this first example single span beam because we are going to model a simple beam element in this first tutorial. Then we can also enter a description for our model. Let's say since this is the first video, we call this tutorial 1. And in the section below, project name, we can organize all of our project. I've entered modeling in RFEM 5 as project name, and if you'd like to add a new project, you can do so by going to create a new project and then simply enter a new project name, choose where to place it. Next, we can define the type of model, and you might notice that we have 3 options for a 2D type. This is because we can define the plane we'd like to place the model in. Let me show you real quick what we are going to model in this example. It's gonna be this very simple beam element with a distributed and a point load, and for this we don't need a 3D structure. That's why we will go with a 2D type in the XZ plane. Then on the right side, we can classify the load cases and combinations we'd like to use. According to any standard we'd like to, we can create combinations automatically, but for this example, this is not going to be relevant, and that's why we choose the option none here. Down here, we can set the orientation of the global z-axis. I'm gonna leave this as downward, but it's a question of personal preference, so if you'd like to set the global z-axis upwards, you can do so. And then we click OK. And we can get started with our first model. So now, which options we do have in RFEM to enter model data? Basically, we have more than one. We can enter model data utilizing these tables down here, or we have dialog options. And we could also enter model data graphically. I want to show you guys any of these options in individual videos, and in this example we will start with the tables down here to enter all of the data we need, such as nodes, members, loads, also supports, and in the next upcoming videos we will then continue with the other options. So now if we focus on this table section down here, we have 4 main tables. The first one is for model data like nodes, lines, materials, as well as cross sections and so on. The second one is for load cases and combinations. And the third one we can use for defining the loads we'd like to apply. But since we don't have any load cases, we cannot enter this table for now. Same here, the last table is the results table. Since we don't have any results yet, we cannot enter this table, but this will change later. Once again, this is the beam element we want to model, and we will start with the nodes. For this, we will go down here in the nodes tab, and we'll enter the 2 nodes that will define the length of the beam of 3 meters. We will set our first node in the origin, which will be 0 and 0. The second node will be 3 and 0. And now we can see in the graphical area that our 2 nodes are created. As I mentioned, I'd like to apply in the middle of this beam element another load. And for this, we have also to create a third node, which will be 1.5 and 0. Next, we jump into the Lines tab. We want to create the line between the 2 nodes, and we can keep the line type as polyline. Node numbers, we can enter here 1, 2. Then we hit enter again. As you can see, the length of the line is automatically determined as 3 meters, and up here we can see this line now. So the next step is to define our material in the Materials tab. We can do this by entering a material name and define the properties of this material manually. Or we can also open up the material library if we click here on the 3 dots and select based on different standards of material. We can cancel out of that. Like I said, I like to keep this example very simple, and we will set a new material with the following properties. I call this one material 1. The modulus of elasticity will be 2300. As Poisson's ratio, we will enter 0.2. And if we hit enter, you will notice that the program automatically puts in here the shear modulus. The other 2 columns, we can keep that as 0 for this example, but we have to enter a partial factor of 1 that we can run the calculation later. Since we have a material now, next we will go over to the cross-section tab. And again, we can simply enter a cross-section, or we can open a cross-section library. As you can see, we have a lot of options for various cross-section types. For this example, again, to keep it simple, I'd like to choose a very basic cross-section, which is going to be a parametric cross-section. This one here, which has a width of 100 and a height of 200. Then we click OK, and to assign this cross-section to a line, we jump into the Members tab, and we select the line by clicking on this little arrow. Then we can simply select the line in the graphical area. Member type, we can keep this as a beam. For the start and end of the beam, we can select different cross-sections. For this example, we are going to keep that as the same. If we enter now, we can see that the line has been rendered into a cross-section. Now we are going to set our supports in the tab Nodal Supports. And for the first node, we can enter here 1. The axis system, we can keep that as the global XYZ axis. In the next columns, you can see the Nodal Constraints, which can be defined and selected for each degree of freedom. For the first node, we will unlock the rotation around the Y-axis. And for the second node, we will allow this to be moved along the X direction. Now we have entered all model data that we need, and we can move on to the next table, which will be the load cases. Since this is a very first simple example, we will define 1 load case. Let's say we enter here load cases all, and the only thing that we should consider is that the self-weight should not be activated. And now, since we have defined a load case, we can also enter the table number 3 for the loads. We will start with the member loads, and the little cursor button here will allow us to graphically select the reference member out of the model. Then we will apply a member load of 5 kilonewtons per meter. Now you can see if we hit enter, our information is entered in a table, but you might wonder why we cannot see any loads. If you like to see the loads, we have to go up to this button here called Show Loads, turn this on, and now you can see that the loads are displayed. Moving on, we are going to add a point load. For this, we jump into the tab Nodal Loads, and we can enter here 3 for the node number 3. As load type, we have force in the global z direction of 15 kilonewtons. To run the calculation for this beam, you can go up here and hit the symbol. Now we can enter the results table, and we have also a new tab in the project navigator where we can display the deformation as well as the internal forces. If we expand the members tab, we can choose and display, for example, the moment or shear forces. To see the results better, we can turn on the wireframe model. And apart from that, down here we can display the support reactions. So guys, this was the first part of modeling in RFEM 5, and we will continue in the next part with modeling a cantilever beam, but this time using the dialog options. And Thank you for watching. If you like this video, don't forget to like and subscribe.